As you know, planetary observing is in the full swing right now. And you have Venus after sunset, you have Saturn, you have Jupiter, and you have Mars. And between Jupiter and Saturn, you have Uranus and Neptune in the distant. So, if you're a planetary observant like I am, this is a real treat. And of course, Mercury is in the morning sky, but it will return to the evening sky next month. And you have all the planets, including the five naked eye planets, visible right after sunset in the evening sky next month. And of course, you have Uranus and Neptune in the distance. It will be quite a treat there for planetary observing. Right now, I'd like to narrow down to one specific planet, which of course will be Mars. Now, tonight, I would be gladly to present my thought, Mars 2025. Okay. Every 2 years in a month, or 2 months, Mars comes to opposition, so we really can see it clearly. Midnight skies at the closest possible, the brightest possible, so we have a really good view of Mars, and that's what's coming up right now during this time. All right, before I go any further, we have old friend back. Get off the planet. Mars is back in the evening sky, so it will be visible for the rest of the year. Okay, and so there would be a good time to take your telescope out and look at Mars right now. But right now is the best time to see it. But eventually, it will be well observed for the next few months, and it will be visible for the rest of the year. Well, before I go any further, anybody had any Mars favorite movie? Like when you're growing up, you have like Invaded from Mars, The Last Day of Mars, The Ghost of Mars, The Wizard of Mars, Last Mission of Mars, The Last Day of Mars. I'm pretty sure one of you, I know you have a favorite movies too. So anyway, my favorite Mars movie is The Angry Red Planet. Yeah, I like that one. And I remember some of the people saw this in the movie house back in 1959 in color. That's amazing. They made it in color, and it was a very popular movie back then, a science fiction. So it's rated as B science fiction movie. So yeah, so though they were made here. It's an actress, Nora Hayden. I don't know where she looked out the window, she saw something scary. You know, the idea of the story is that there were four astronauts who came back, who passed away, who came back, and she was left alone. And so I don't know, she was very confused and all. And they have some kind of flashback, and she was telling the story what happened when they were there. So that's the idea of the movie. Yeah. So when she's looking out the window, she was like marching with bulgy eyes and something like that. And it's really trying to see they don't want them to rule the world or something like that, whatever. And I remember as a kid, I saw that on television, and this is one creepy feature that really scared me off. I don't know what it was, maybe a bat or a crab or something like that, but it was very creepy. I was like this, and it was very scary and all. So, yeah, so I don't know what happened. It was just that used some kind of gun or something like that, and was pointing, then got blind or something like that, and went away, something like that. Well, that was pretty creepy. Anyway, let's talk about the real Mars, okay? And we have the Earth and Mars, and we can see that Mars is it's half the size of the Earth. The Earth's diameter is almost 8,000 miles, and Mars' diameter is about 4,200 miles. So it's in the size between the Moon and the Earth. So really, Mars is it's a small planet compared to the Earth. Okay, we all know that Mars is more like Earth-like in some ways. Mars stays about 24 hours and 39 minutes, a little slower than the Earth. The Earth is 24 hours, and Mars is 24 hours and 39 minutes. So they extra 30 minutes, 39 minutes to make one full rotation. So Mars day, like it's Mars 24 hours and 39 minutes. They rotate only 350 350 degrees, 24 hours. Our 24 hours, Mars rotated 350 degrees, and central longitude back around 10 degrees per day. Well, let me explain that to you. Let's say you're observing Mars through the eyepiece, maybe 9 o'clock. 9 o'clock in the evening, you see Mars like this, okay, on the Monday night. And you see all the details and all. Now, the next night, Tuesday night, at the exact time at 9 o'clock, it seems to rotate it backwards. All right. But the idea is that it's not really rotating backwards. It's a little slower. Then you have to make up another 39 minutes to see exactly what you saw the night before. So if I keep going on the Wednesday night, you see the stuff to get rotated backwards. But it's really rotated from right to left. And so that's why it's a little slower each night you see Mars at the same time, Friday and Monday, and it seems here. So the feature right here was right over here in a week before, but they have to make 39 minutes each night that you made up to come on this side here. Here. Okay, so that's what it looks like when you observe Mars exactly every night at the same time. But I'm going to explain that a little later. And then this is Monday night, a week later. So, yeah. Okay, I want to go back a little bit to the very first time when I observed Mars. This is my first observation, my first report, first drawing of Mars back in August 1971, when I was a kid. It was the very first observation of Mars, and of the favorable opposition. And I remember I was telling this is August. I remember I was telling my father I wanted a telescope for my birthday so I could see Mars at the favorable opposition in August. That's where my birthday is. So I got my telescope just in time. And Mars opposition in 1971 was on August 10th, if I remember correctly. So this is about just a week and a half after. Mars was like 25 arc seconds. So even 150 power, I wrote down. Many detail was visible there. And even drawn in color. Imagine that in color. That's what I saw through the eyepiece. Then it's just a few days later, and again, just the searching major, one of the most prominent feature visible in here. This is the polar cap here. So August 24th, 1971, again 150 power, and I drew in color with the color pencils and all. So that's what I saw through the eye.
What telescope was that?
Okay. They were taken with a 4.5-inch Costco reflector.
Refractor?
No, reflector.
Reflector, right?
Yeah, yeah, yeah. 4.5. The Costco telescope was very popular those days, though, back in the early 70s. And the following opposition in 1973. Now September's 1973. Now I get a little more technical term how to report the observation by using universal time, 4 hours universal time, which is midnight our time, and 48 million miles and 17 arc seconds, and the magnitude is it's hard to read. Oh, the magnitude is minus 1.5. Central meridian longitude with 230. So I already know the technical term how to report. To report the observation, and I wrote it down here. What I saw, what I think it was, and even though I go in color, and this is a band here, certain major, the most prominent feature was right here, and so I got a good head start, and so even though I continue here, October 3rd, 1973, and I wrote down all the information there. So as a kid, it's pretty amazing, all the technical terms to write down the observation, describe it, and even the polar cap is still visible but shrinking. It's right up here, a little dot there.
Frank, how old were you when you took?
I was about 15 years old. Yeah.
That's
Yeah. And I was 13 years old when I got the first telescope when I observed in 1971 that position. Yeah. And again, October 13th, 73. Now, look what happened next. What happened was there was the dust storm. I could not see anything on Mars. And yeah, then so in mid-October 1973 and on, there was a global dust storm. But I didn't realize what's going on. Was as a kid, what you know? But I was complaining to my father that there's something wrong with the telescope. I cannot see anything on Mars anymore. Yeah, it was a dust storm, and so it was like a very quick. Yeah. Um, so it was just nothing but a blank disc. I couldn't see anymore. So I stopped drawing, and there's nothing to see anymore. But then I realized I I did Sky a Telescope magazine. At the end of the year, they have a short article that they were the dust storm development at the time when I was observing. So right away, I don't understand why I didn't see anything. So, okay, all right, now ARPO, it's Associated Lunar and Planetary Observer. Okay, that's the group I belong to, and also the staff, and also a Mercury coordinator of the Associated Lunar Planetary Observer. But within that group, it's the study of the solar system by amateur astronomer and a professional astronomer too. And it's where we keep all our data, records, observation in one big place here. So within that group, you have Mercury, you have Venus, you have lunar sessions, you have Mars sessions, Jupiter sessions, Saturn session, remote planet session, which consists of Uranus and Neptune, and Pluto too. Okay, I don't leave Pluto out. Of course, addition to that, you have asteroids, you have minor planet sessions, you got your rose sessions, solar sessions, comet sessions, meteor sessions, and all that. Even exoplanet session too, exosolar planets. And so there's a lot of session within the group here. Um, so there's a very well organized group. Of course, I associate with the British Astronomical Society, British Astronomical Association (BAA), and also Outpost Japan. So we all work together, and we have like a global view of any planet that we're observing. So,
Right. Do you submit reports or do you have like a quarterly that you put out?
yeah, the Diapo Journal report quarterly, every 3 months. So yeah. And they have all these articles about, anything, any solar system related articles, papers, and all, or upcoming events. So, okay, it's one of the journal in the spring 2010, and you can see my observation um, of Mars here, and also another image of Mars by the late Donald Parker. He's a very well-known planet observer from Florida. Um, he, 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 he was very good. This and the idea is that we both observe Mars at the same time. So simultaneous observation on January 23rd, 2010, and we observed the same thing, same time, and those are white clouds here, and observed the same thing on the side here. Yeah. Uh, at that time, when Mars was very close to opposition, so you can see a full disk, and this is the most detailed you can see here. So the idea is that when you have this kind of observation, it's always good to confirm one another. So when we have two persons observe the same object at the same time, confirm each other. Yes, I show this, I show that, so we're able to confirm it. So that's the idea is. So that's a very well documented. Okay, now back in 1988, there was another favorable opposition, and I made a short animation of the full rotation here. Now, this is done by film, by the hypersensitized film that I use. Those were during the dinosaur days. So you're able to see the rotation, the full rotation, about a month, something like that, and you can see maybe a feature rotated from left to right. You know, the next one, now 2003, you can see a little better. Now you can see all of the south polar caps. You can see the features. Now, if you keep your eye on the polar cap, you can see that it's melting, and all of a sudden it just like disappear. Yeah, but that's about 2 months worth of observation here. At the beginning, you can see that like a full cap on the path, and then as you see Mars rotate about 2 months later, you can see that's getting smaller, smaller, smaller until it's no longer visible. And you can see the eye of Mars. It's certainly measured here, the most prominent feature. The eye of Mars is very, very impressive. You can see all the detail here, right here. You can see all the details around there, all the spokes-like. Amazing, yeah. So there's quite a big work to do something like that. I spent a whole night to put everything together, make sure they don't jumping around, and crop it properly, uh, and make a decent, a nice animation. The next one, now 2016, and you see another more animation than made, the full animation. So, and you can see now uh, the North Polar Cap down here. So now this is 2020. Now you can see the polar cap, the South Polar Cap here. So you can see all the detail. Very nice. Yeah, that's doing a favorable opposition 2020, 4 years ago. This is from September 20th to the 31st, 2020. So that's like again, it's quite a big work to put everything together, make an animation like this. So you make sure you cover all the detail and on a full 360-degree global view.
Right. That's every night from September 20th.
Not every night, maybe I would say every 3, 4 nights. Yeah. Yeah. Okay. Let's give you a little view quickly. Some view from 2022, the last apparition. So you can see that the polar cap was visible, the South Polar Cap, and some of the details here. And when you headed into the Mars session, you know, they preferred all the details here, information. They wanted like a UT, the longitude and the degree, how much the South Polar Cap or the Southern Hemisphere tilts toward the Earth, the 21 degrees south, and the sea condition, and the type of telescope, the camera, and the person, and where the person lived. And these are the longitude for the orbit longitude around the sun. This is arc-second, how big is the diameter? And this is 44 degrees, I believe, at some kind of inclination of the orbit, something like that. I don't remember offhand, but they prefer this kind of information in order to get well documented. So as I go along, you can see that Mars is getting a little bigger. You can see more details of Mars getting closer to Earth. And this is a color camera, but I'm going to get more details. This is a color camera, and this is the black and white camera with 660 bandpass, long pass filter. So that's like a red filter would help increase the contrast. I'll talk more about that later. So, you know, they prefer something like this to get the document. And of course, as Mars getting bigger, you can see more detail. You can see the details around the North Polar Cap here. So this is something like this.
The 610 nanometer for black and white.
For black and white, yeah, to get the increased most maximum contrasted possible. So, yeah. So let's give you an idea what it'll look like through the telescope. So, you see here. And again, here you can see the North Polar Hood. Now it's not the North Polar Cap. Don't forget, this is south, up, down, and east and west. This is the hood here. They don't know the relationship between the hood and the cap. It's, it's not very well understood. But the cap is it's the water vapor that cover the top of the cap, the North Polar Cap. There's some kind of vapor that when the spring arrived there, it helped to increase some kind of water pressure in the atmosphere, something like that, and it caused the water vapor to form the hood over the caps. So I'll show you more about that. Yes. You made water ice crystals. Yeah. And of course, you see more here. Now this one here, like that here, that's the Olympic Mons. That's the tallest mountain, tallest peak on the surface of Mars, much higher than the Mount Everest on Earth. So it appears very dark here because it must be some kind of dust layer. And what happened then this area here in the top of the shield is above the dust layer, so that's why it appears darker than the surrounding area. And you will see more of that. And now, as you can see, more detailed here. From what I understand here, it's some kind of polar front right here, and this is the south north polar cap here, and some kind of front here, right here, during during the spring. So I don't remember offhand what would they think they occurred here, but there's some kind of polar front that caused the clouds to move here. So yeah, there was some kind of information from other observers. They saw the same thing. So, and again here you can see it's getting larger. You can see the polar haze back here. So don't forget this is spring in the southern hemisphere and in autumn in the northern hemisphere. As you can see on the details here and there. And now it's getting smaller because it's past opposition. Now you can actually see the North Polar Cap right here. So that's yeah, it's a spring in the southern hemisphere. And then it gets smaller and smaller. Yeah. Okay. Now, Christopher Lowell is one of the famous planetary astronomer back in the early 20th century. He's from Boston area, and he's very interested. He got interested in Mars observing later in life. The idea is that he became well known about the canal on Mars that you see over here. There's the map he drew, and then you always see all these streaks around. And he was electrified by seeing the crisscross on the disk. He come out with the idea, oh wow, there must be intelligent being on Mars, and trying to get the water from the North Polar Cap where it's melting, and it make the pathway, make the canal, so that's why the water can go down to the equatorial region from the polar region, from the polar cap to around the equator. And so, you know, to make a long story short, a lot of professional astronomers they dismiss that, but one thing he was right. One thing, even today, Mars look like a dying world. So they really see that. Here are some of the sketches he did. All this line, he put numbers there. I don't know where they mean. You see all this line here. It's the eye of Mars that I showed you. Remember the round thing with the eye in the middle? So it becomes like all this canal here that connected the hub, that connected one. You know, it's really don't know. I mean, he didn't start with the canal. It was Giovanni Schiaparelli, the Italian astronomer, back in the late 1900s. He started with called canali, but then he converted to the English word canals. So Percival Lowell took over when he established his observatory in Flagstaff, Arizona, in 1894, and so he took over his work. And he continued. You know, he was amazing by what Schiaparelli saw, and so he took over, and he you know he made further observation here. He really did believe that he saw the canal there. But
Right.
yeah.
Didn't this turn out to be blood vessels in his eye?
Yeah, okay, yeah. I was going to mention that. Yeah, a little later on, they made some kind of research. Why certain people see some kind of canals, not only on Mars, but even on Mercury, Venus with the spoke system, even in Jupiter satellite Ganymede that show all these lines here. They come out with the idea is that if you observe at a very high magnification, a very high magnification, you're looking at through the small lens, you actually see some kind of reflection from inside your eyes. What you see is actually blood vessel instead of actually canals on the planets, not only Mars, but other planets as well. But that's what I mean. You always see what he was using the 24-inch refractor at that time. And it always a high magnification, 1,000 times, 2,500 times. I mean, very rarely you hear that today. But back then, they were using high magnification. So they theorized that when you're looking through the very high eyepiece, through this very small lens, you actually see the reflection inside your eyes. Then you see, like you see the floaters. I'm pretty sure many of you see the floaters. Yeah, it was something like that when you're looking at a very simple, very narrow field of view, and you see the floater, and also you see part of the blood vessel. You see all this line, and right away you assume that you look at the plan, you see lines also, and they think it's the way they saw it. They do something like that, but there are some cases that it does look like that, but in a different way. I show you that in a moment. And as a matter of fact, the next slide, just want to show you here. Now, this is one of my favorite shots back in 2020. And if you look carefully, you can see all these lines here. Okay, you see all these dots here. Back then, they're called the oasis. Oasis is like a body seat of water. So you can see all this line here. Here's a close-up shot, as you can see all this line here, and I make the connection here. It does look like a canal, right? Almost, yes. But the idea is when you look at a very high magnification, you see all this line, they broke up into notches. They say with some kind of a wind streak. Okay, yeah, there's a lot of wind streak on Mars, and probably that's what is occurring right now at that time. And these they're not body of water, they are floor, they are craters. Start with a dark floor, very shallow crater, and it appears very dark floors. So that's why it appears like that here. And back then, they didn't know the true nature of what they saw. They right away they think it's the body of water. So that's why it's called the oasis. And here's here one right here, there, and see all these lines here. So it does show sometimes you see like a crisscross here, yes, but not the canal, but it's probably the wind streaks, and it had to be occurred during a very excellent seeing condition to see something like that. You see like a small crisscross like, but that's not what they saw like Paparelli saw back in their days. Hit another shot here. Back in 1924, another son, George H. Hamilton, it was observed with the 11-inch refractor telescope, and that's what he drew here. And my image right here, it's almost similar. You're looking at almost the same part of the surface. And he drew a little circle here. Okay, that's Olympic Mons. Back then, they don't know the true nature of what this object is. You see something round there, and you see all these lines here. This is solid lacus, the eye of Mars, surrounded by lines of crisscross here. So it was probably exactly what he saw. And compare my image, it's almost the same feature here. Here's solid Lucas. Here, you see all these lines here, the same thing as this. Now, Linton Mons, it's right over here. See, you can able to see a little brightness variation right here. And so what you see here is almost what he saw there. So that's quite amazing. So they're very careful observer, and just see here, they were talking August 22nd and 23rd, 1924. So you're talking about 100 years ago. Yeah, now this is one of the fine drawings, and compare with my image, it's almost similarity. It's very striking similarity to it. And here's another shot here. Same person, he drew all these lines here, and this is another feature here, Sabia sinus and meridian sinus. And here's the photograph. So the idea is that he shows some kind of lines here, connect here, right here, lines here. And he claimed to see here, but I don't know how well you can see from where you're sitting, but very close, you see some kind of line here. And everything looked like it's connected here. Now, here's my image here. And this portion here, I enlarge here. If you look carefully, you can see this line here. I even do this here. And there's some kind of connection here, right here, there, and here. But I really don't know what they think the soil was. The thing looked like a canal here, and it looked like the canals right here too. But it is very similar for what they saw. But we know that there's no canals, but there's probably a wind streak or something like that. As you can see, even this one, you can see this here. So a very excellent resolution. You can able to catch very fine detail. So yeah, here's another shot here. Olympic Mons. This was taken with the Viking orbiter, and you can see there's a big volcanic mountain here and a shield here, but it's very shallow, very shallow. It's the peak is very high, much higher than the Mount Everest, but it's spread out. Now, my image here, as you can see right here, you can actually see the brightness variation here. Hit the base here, right? Hit the close up right over here, and hit the base here. The same thing what you see here, and you can see the brightness variation. So this is probably one of the the observer back in the 1920th century saw something like that, and you can see the connect with lines here, like a canal, but there's nothing to it. But sometimes you can see wind streak, like I show you the other image. Yeah, you hit another shot of Olympic Mons, as you can see from this area. I blew it up, as you can see this area right over here. See, you can see the little color variation right here. So at that time, Mars was 22 odd seconds, so you can really see the very fine detail. So, yeah. Okay, here's another shot here. This is the valleys of the Marianas. Yeah, this looks like a Grand Canyon on Mars, like you see on Earth in Arizona. Here's the fine shot I took, and you can match very well what you see here. For example, these are dark. You see what I say? These are dark, like to say oasis or something like that. But this is actually the dark floor of the crater. There, that appear very dark. So it's enough contrast to see it. So all these three prong lights, as you can see right here, the prong that's like a three prong that's like a taken out right here, there, and this here, this is the canal, the canyon here, is that dark streak right here. And of course, it's then downward here, and the continuation here, and you can see right here, it's down here, right here, all this here. And there's another one right here, this part here, this part right here, and this section here, and it's right over here. So yeah, so when it's really clear like that, you really can see the feature. And back then, we don't know the true nature of what they saw, but thanks for the satellite, we can able to confirm and help us what we understand when we see Mars close. And of course, this is a volcanic region right here, but I guess it's not enough contrast here, so it should be down here, but it's not visible. So this is a pretty fine shot there. So yeah, so when it's really clear, really close enough here, you can able to see the feature here, and you know what you see here. You see, this is the area right there.
To give a sense of scale, the Valles Marineris is the size of the United States.
Oh yeah, almost. Yes, it's much bigger than the Grand Canyon. Almost the size of the United States. Yeah, yeah.
Which
It's just-
part is Valles Marineris?
The whole thing, whole area.
Oh, that's the size. of
Yeah,
the
the whole
state.
area
Okay,
is this
right.
here. The canyon right here. Now the reason is we don't actually see the canyon, but we're able to see the color, dark blue color here. All right, so we don't see the canyons like we can see on the moon. So we understand what we see here now. The dark floor. You only see the dark floor right here. And here, some blotches here. That's what we see here. The same thing with dark blotches right here. Yeah, these are floor craters there. Yeah. Okay. Let's see. All right. Now let's talk about Mars now this year, 2025. So we're gonna see what what we can observe. Okay, March 2025, opposition will occur January 16th. That's next week. Okay, so the closest will be January 12th, which this weekend. Now, why? Theory, uh, actually, when it's an opposition, usually the closest. All right, but not necessarily so in case of Mars. Because Mars doesn't have a perfect circle orbit. It's elliptical orbit. So one point in the orbit when it's close to the sun, another point in the orbit it's furthest away from the sun. So the idea is that Mars, as of right now, is moving away from us, moving away from the sun. Now, in January 12th, it would be close enough, not opposition, but would be close enough. But then 2 days later, by the 16th, Mars would move a little further out in orbit at the same time the Earth moves in orbit. So Mars will be a little further out. So that's why it said that the close will be on the 12th instead of the 16th. So that's why.
Frank.
Yeah.
But still brightest at opposition, correct?
Oh, yes, yeah. It's just a matter of so many miles. I mean, it's not a big deal, but specifically, the closest would be the 12th. No. Yeah. It will be 16 million miles. The closer it can be, it's about 34.5 million miles. That's going to be a favorable opposition. So it's really, really further out this time, 16 million miles. It will appear at 14.6 arc seconds. It's not very big, but you need some magnification to see Mars really well. Like I said, the larger can be at 25 arc seconds. So it will be 14.6, so it will be smaller. It would be minus 1.2 magnitude. It's pretty bright. It looks like one of the brightest stars in the sky, but not as bright as Jupiter and not as bright as Sirius, the brightest star. Now, Sirius is minus 1.4, so it almost looks like the same brightness star. So it would be pretty bright. It would be plus 22-degree declination, so it would be pretty high. So when it's really high in the sky, you can get really good seeing. You can really have a good view of Mars. So be high enough to have a good view. It's about the same altitude as the 22 apparition, so it will be just the same. It won't be lower or won't be even higher. So it will be the same height, same altitude as you see in 2022 compared to this one here. Okay, it will be in the constellation Gemini. All right, now, of course, it won't be as big as the full moon. It might be over here tonight, but actually, if you use the magnification to the telescope about 150 times to see Mars, it would be as big as the moon, as you see with the naked eye. But you need 150 power magnification. So, in other words, if you look at Mars with one eye to the 150 power, and you have look at the full moon with your left eye, you can see it the same size at the same time. Okay, here's a view of Mars and Earth orbit view from above, and this is all the opposition occurred in the past, and October 2020 and 2022. And currently, we on this one in January 16, 24. You can see when the opposition, the Earth is between Mars and the Sun, and so they have Mars and the Sun totally opposite sides of the sky, and that's what's called opposition here. And if you look at the past, it's 2022 here, and the past 2020. So as you can see, that it's occurred every 2 years and 2 months. So 2012, 2014, 2016, and so forth. Now you look at the path, a full path what Mars will be in the sky. So you can see the start from July 2024, it was in Taurus, and you can see the movements here, and all of a sudden it stopped and goes backwards. It wrote the great motion. I mean, as the Earth is approaching Mars, the Earth is moving much faster, and Mars appears going backwards according to the background. It's really not going backwards, but the Earth is moving much faster, and the Mars appears to go a little slower, much slower. They look like it's going backwards. So as of now, January 8th, Mars is right over here compared to the constellation Gemini and Cancer. So by the end of the month, you can see it again closer to Pollux and Castor in Gemini. You can see it there by the end of the month, and by February, it will be right here. Then by February 25th, I believe, yeah, then we'll resume eastward motion. Then it go back this way here. And then by the springtime, it will be Cancer. And by June 15th, it will be in the constellation Leo, Regulus. It will be right near Regulus. Yeah. So, yes. So this is a closer view. You can see Jupiter. Remember last summer, Mars went by Jupiter. It's right here, and here's a closer view here and there. Retrograde, make it like a loop. There, here, go backwards. Now opposition is right over here, right in the middle between two stationary points. Right over here, you can see at opposition next week, Castor and Pollux will line up with Mars. It's like a three straight line. So you will see it next week. Right now, right now it's right here. So right now it doesn't line up here, but next week will line up. So you actually see, night by night, you actually see the motion that Mars is moving backwards. And it will pass by mid-February next month. You can see it will form a triangle shape with Castor and Pollux. So it's amazing. You're able to see nightly see the movement every night.
Be on May 6th there, and it'll be right next to the Beehive cluster.
Oh, right here, right? Oh, May 6th, yeah. After resumed eastward motion, as the Earth pull away from Mars, and Mars will assume the eastern motion, then it looks like it's going direction eastward. Yes, by May 6th, it will be right by M44, the Beehive cluster. So it will look like we'll pass north of it. So this should be a very good view. If the sky darken up, you can able to see naked eye. Otherwise, you use a pair of binoculars, you get a good view of M44 and Mars number 6. So, yeah, so it will continue this way here. So. Okay, this is the general view of Mars, general map, location. They show the location of each object. There's the latitude here, longitude here. So this is like a general view of Mars map, what it looks like through the telescope. And here's another view here. They have a list of objects here. Here's 13 major, Mars Sirium, Severe Stibans, Meridian Stibans, Rho Sinus, Mare Acadelium, and so forth, crises. So here's the latitude here. So this is the southern hemisphere. So Mars are always upside down, because that's the way we can view Mars, because it's recognized by international astronomical union. They prefer south.com. So here's a global view of this session here. The 13 major right here. So each global view here represents this part of the map here, and so on. So. Okay, here's another view. This is a little more simple. So you can able to identify what you see on Mars, all these features there. Okay, now about imaging. I used to do webcams. It's a fast frame rate, beat the scene, right? Okay. When it comes to imaging, this is most likely I use with the DOW SIA 120, the color camera here, and this is the black and white camera, the DMK imaging source. All right, so I use this for black and white, but I use this for color here. Now I do have another camera. Instead of to be 120 is 290 inches. So it's a little more advanced. The chip is a little bigger. You get the same kind of maybe a better resolution, more faster camera, faster rate or something like that. But it's very similar to this one here. And the software I use is the IC capture for black and white. All right. This is very good software capture with the black and white DMK image source film. So uh, so this is very good for caption with the black and white camera image source. And for color, I use a fire capture there. Once you open up the fire capture software to capture the image, it will look something like this. You have the camera, you control the pixel, how big is the frame here, the shutter speed, the exposure, the gain, the gamma here. They have often more exposure. Mars is a type of planet, whether it's the RG color or black and white, or not black and white, whether it's the blue filter or green filter you use the AV file. No limits. I mean, you can let it run as long as you want. Here's the status. It can tell you how much disk space you have, and this is the histogram. It's to show you, how much brightness you have. If you go beyond here, then it's going to be overexposed. So usually around this range here. Yeah, and it's all this menu here, whether you want to hold the line, cut off dark frame, ephemeris. So yeah, so this is a general view, what it look like when you capture with the ZOW camera. Of course, you can, you have everything here. This is for crop, this is for information, and so forth. You can adjust the color balance and so forth. Yeah, does it very well. This is most people use this software for planetary capture.
And it's good because you can learn the whole program in 5 minutes.
Oh yeah, 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 yeah. Well, it took me a while to learn all this. It took a while.
Yeah.
Yeah, but you learn as you use this, as you use it now.
You focus by hand each time, or you have a autofocus?
No, I focus manually. Yeah, but they do have a focus help. Yeah, focus help. Yeah. Well, you place in the middle, and when you focus it, they have some kind of line, whether if it's too blurry or one of the straight line that made exact focus. When the line goes up, it's out of focus. So it does help, but better to use by eye. And to stack the images, I use like a stack 6. I use for black and white. It's very well. They have all this version. I start with version 2 now all the way to 6. I think that's the highest one so far. But they have smaller version of like a stack 6. I forgot what version I use, but yeah, this is very good here. You can able to set it to default, and it would do by itself. If you want 3x3 area, how much you want to set up the how well you want to align the image. And then over here, there's a limit box. If you want them like this or you want a small, depends on the size of the planet. Like Mars and Mercury, they're very small, so I use the smallest box to align. And how many images you want? Your best frame, go by percentage. You want the best frame, how many? 200, and so forth. So now you have to play around with it. So there's no perfect setup. Depends on the object, depends on the planet, depends on the brightness, the size, and so forth, and the sea condition too. So you want to get as many best frame as possible, then you put 80 or 80%, or you want 50%. If you take 10,000 images, you want to collect only 5,000, so 50%. So, want to get, it will collect the first 5,000 images best as possible. Yeah.
Is this, image capturing software or post-processing software?
This is the imaging.
This is imaging.
Yeah. Yes.
Okay. So it hooks up to your bill.
Yeah. No, this is, I'm sorry, this is stacking. This is for stacking.
Where's that?
Yeah, for stacking. Yeah. The image that I show you is this one and I see. Yeah, that's for caption.
That's for caption.
Yeah, and after that's done, you get the raw image. Then you stack for how many times. Now once you stack all the images. Oh, but no, this is yeah. All right, this is one, and this is another one. This is auto stacking. I use it for color. This is auto stacking. Like you open up here, you open the file and get the raw image, and then you place it here. Raw image will appear here. Then you put the box there, exactly where you want to stack them. You put how many frames you want. Over here, how many frames? Well, they go by percentage. So if you want 50, like if you have 10,000 frame and you put 50, it will collect 50% of the best frame that means stacked. Whether it's local or global, all that stuff. Then over here, this is the gauge. How much is how much time you have left. Yeah, although you want the number of frames to stack, you put the number here, or you put the number here, but the percentage. So if you have 10,000 frames, you got to stack, and you want only 5,000, then you put 5,000 here. Like that. Then you put the number of the size of the box. Its Mars is really small, and you can put the numbers. We put 104 pixel size there, and then you press here, play. That it was stacked. You see the gauge up here, it was stacked. Yeah. So that's a pretty good software for stacking images, and it works very well. Yeah. Then, if you stack them, then I use the Astrosurface for processing, like adjust the brightness, the contrast, crop it, rotating, and and so forth. So this is very good process. All the images that you saw, it was processed in the Astrosurface. This is very good. Then you can do anything with it. Rotate it, crop, resize. If you want to make it bigger, a level, the level of brightness. You want it to bright, then adjust the contrast. Black and white points, exposure, whether you want it brighter or more contrast. The gamma level. And I don't use this 8-16-bit. I use that noise, whether to reduce the noise, and alignment red, green, blue. If you see like a blue fringe on one side and a red fringe on the other side of the disc, so it looks like the color's a little bit off. You click here, and that would help to reduce the fringe color that you see on the edge of the planet. Of course, you gain brightness, red, green, and blue. Saturation, if you want more coloration or you want a little less color. Or your devotion, Lucy devotion, Richard software. If you want to make it sharper and undo, if you want to go back what you did, if you don't like it, clear, waveland, and so forth. So this is the sort of main view, main files that you use. Of course, you have if you want to boost it up to see the planar object, invert the negative side, and reset if you want to put it set up the way it was before. And so this is pretty good. So for a lot of planetary astronomers use the Astrosurface, so this is very well written.
Right.
Yeah.
There's a charge for this, or is this
No, it's free.
so?
Yeah, it's free. Yeah. So they come out with a different version. I forgot what version they did, but sometime when there is upgraded version, I don't really like to do that because sometimes when you upgrade something, then you got problems. Something doesn't work out or something like that. But the older version works fine. If you're happy with it, stick with it. sometimes, like I said, if you upgrade it and you have problems and it doesn't work out, though, then you can do anything. You go back to the old version. So I keep my technique very, very simple. Some other planetary observers, especially the European observers, they're very good, and they come up with all the updated version of the software and details and all. They really worked out, but you got to know what you're doing. But like I said, I keep my technique very simple. So okay, here's some preview of 24, 25 here, and then I started with Mars back in May 31st. All right, May 31st. It was still very very more small, 5 seconds. So you need a very high magnification, look very, very small. But this was taken in daylight. Okay, so it would take it like 13 hours, 40 minutes universal time. That's represent 9:30 in the morning too. So this is black and white and this is color, and you start to see details already here. So the idea of why it's daylight, because that's when it's high in the sky. And unfortunately, I don't have a good eastern horizon. Now with Mars visible that morning, May 31st, it was very low. So you're dealing with the 5 arc seconds this diameter. You gotta have a very good seeing, and you weren't able to get to do this kind of image like this, what you see here. And in daylight, it was high in the sky, but you have to be lucky enough to see fine in daylight. You got to use some kind of setting circles and so forth. Here's another image here. Now you're 5.5 arc socket. Now it's getting a little bigger. If you look carefully, you can see the polar cap, the south polar cap right here. Now it's the black and white and the colored image. So to keep going here, you see the eye of Mars, Solarlacus, right here. There's the black and white color too. And if I keep going, you can see start to get more details there. And here's one here. Then you can see the south polar. I'm sorry, the north polar cap here. Start to see here because spring is arriving in the southern hemisphere. That's what we're seeing right now. And it's more. Now you can see it getting bigger. October 19th, November 14th. Now it starts to get bigger. Now the bigger it gets, the more detail here. Now you really start to see the North Polar Cap here. This is done with the color camera. This is the black and white. There's the blue filter, and again there's the tape. Now with the blue filter, what it does is to concentrate on the upper part of the Martian atmosphere. Now with the red filter and the color filter, especially with the color camera, usually penetrate much through the atmosphere and concentrates on the surface, goes right to the surface, but not the blue filter. The blue filter goes up to the upper atmosphere, and what happens that the dark background the background is dark because it's absorbing light. Only the high clouds or the graphic clouds is visible and reflects back, and they feel very bright. Now, like the south here, the south pole haze, and then this is the north polar cap. So, like again, the blue filter helps to increase the contrast to see the clouds in the atmosphere. Now, here's another view. Now you can see in December 27th. Look how clear the north polar cap here. Very nice here. So you can see the lowest band. They call the lowest band because, well, Percival Lowell was the first person to recognize as what it was around the polar cap. So it's really because the contrast, the fresh dust is exposed, so it appears very dark, especially when the melting of the polar cap is exposed to fresh dust, so that's where it appears darker. Okay, now this one here, you can see the color image and the blue image. Look at those clouds here. These are orographic clouds. Orographic clouds that's formed around the volcanic region. Now, Olympic Mons, the tallest mountain on Mars, it's right over here. Orographic clouds is it's the water vapor. See, what happened was when there's some polar cap, the north polar cap is melting, it's increased some kind of the atmosphere and it's filled with water vapor. This water vapor, then to fill up the atmosphere. So during the part of the afternoon, the local afternoon Martian time, if it formed some kind of orographic clouds with the winds, but it's upslope against the mountain, and when it's a high altitude, it's colder. It's formed orange water ice crystal. It will form a cloud from the water vapor to the ice crystal clouds. And that's what it formed here. And as you can see through here, there's a volcanic region here. And I have a better image coming up. Okay, this is my last image, January 4th, just almost a week ago. Here's the color image here, and here's the orographic cloud. Now, as Mars rotated by 15, it's a little less than an hour, maybe by 15 minutes, you can see it starts to intensify as Mars rotated from right to left. And you can see this volcanic region. You can see a little more inland, a little more inward here. And 15 minutes later, it's rotated much more close to the disk. It's intensified because the later the afternoon, the brighter the clouds will get. Now, this is the morning side. Okay, so this orographic cloud, it's even on Earth, especially in the mountain area, the orographic clouds is formed even on Earth. Yeah, it usually formed on the local noontime on Mars, and it started to develop as the warm air, moisture, the water vapor move up to the slope of the volcanic region. When it's exposed to the high altitude, then it converted to the ice crystal, water ice crystal, and it form a cloud and flow into a cloud. And as it enter more toward the sunset here, it gets intensified here. Now, as a general rule, they don't survive overnight. When this part of the surface here on the morning limb, it just disappear. The clouds disappear. All right, they don't survive overnight. Okay, give you for example, this is a topographic image taken from the spacecraft, and as you can see Olympic Mons right here, and you can see this smaller volcano. I forgot to remember one name. I think it's Providence Mons or Asian Mons, something like that. These are volcanic region here, and the colors represent the altitude. This is the higher ground here, and this is the lower ground here. So represent a blue color. And here's another one. Now, here's my image right here. Okay, now it's upside down to match with this. Now you can able to see this orographic clouds match with this cloud here. Here's the Olympic Mons here, and here it is right here. And there's another one here. It's the high land, but not as tall as the mountain, and it's visible right here. So you can see here, these are a high elevation, and they form the higher clouds right here. This is also another volcanic region, Elysium, in the morning sky. This is the morning sky here. It is fairly visible, but they're not formed yet because it will form when it's going toward the afternoon local time here. So this is the morning side. And you can see some clouds right here. No. And so that's the idea with the blue filter, able to capture the clouds. Now, at this time of the year, when the polar cap is melting, it's increased the contrast, increased the pressure in the upper atmosphere, and converted from water vapor to water ice crystal, and it formed in the upper atmosphere. Now, with the blue filter, it would darken the background here because it can't penetrate much at the red filter to the ground, and only concentrate in the upper atmosphere and able to increase the contrast of the white cloud, or the graphic cloud, bluish cloud, whatever is visible here. So now is it a good time to do it because the polar cap is melting and it formed the cloud there. This is amazing, it really is amazing. Okay, now filter. Now, when you look to the telescope, Mars is the best planet to use to filter, whether it's the red filter, green filter, yellow filter, blue filter, and so forth. But each filter see different part of the surface of Mars. Now, if you use Rackham 47, which is the violet filter, is the maximum is 470 nanometers, so it's on a blue part of the spectrum. It's good for searching for high altitude clouds, like I explained to my before. Now the blue filter, Rackham 47, is very, very dense, very small. So you have to look very carefully. The larger telescope, the better. But if you have like an 8-10 inch telescope, it should be bright enough to see through the Rackham 47 violet filter. And you can able to, maybe you can see white spots there, and those are white clouds there. Now you're going a little bit down the spectrum. Now you have Rackham 88 blue filter, not as strong as violet, but it still have that high water clouds in the atmosphere. So now you go down to Rackham 58, which is the green filter. This is good for searching for melt line around the polar caps. You see the melting line too. Rackham 12 is the yellow filter. Not much advantage, but you can see many features that you don't see in other part of a filter. Rackham 21, orange filter. That's the best filter used if you want to see the detail on the surface. Best filter for all very fine detail for the surface. So now we go down to the red filter, Rackham 25, which it's hard to see. It's very dense, but if you have a large telescope with good seeing, then you can able to search for the maximum contrast as possible on the surface. You detect dust clouds against the dark albedo feature here. So, okay, now don't forget the evening of January 13th, which is next Monday night. Write it down. If you plan to look at Mars, you're gonna have a little problem because the moon's gonna be in the way. At near opposition, there will be an occultation of Mars by the full moon. On Long Island, the occultation will occur 9:21, just about this hour, and it will disappear on the eastern limb and reemerge 10:37 p.m. It will be very interesting to see whether Mars will be visible with the naked eye that close to the full moon. So mark down your calendar. Hopefully will be clear. Okay, this is the general view where the occultation will be seen. Of course, we're in a perfect spot right here. These are the occultation zone. You go from most of the United States all the way to the west coast of Africa, when it's visible toward the west. So we're in a perfect view to see the occultation. Here's another view. This red circle represents the size of the moon, and moon will cover this portion of the earth here as it moves toward the western Africa. So of course, we're right here, we're in a perfect spot to see the occultation. Now, one question, would it be clear?